after 4 years. So let's go up here and read what the situation is. Suppose you invest $100 each month. That's what's making this into a summation. Because in the past, if I put in money for retirement, I invest it one time and then I get interest every year. But this is new. This is adding $100 every month extra into the account. So January, let's say you added $100, right? Let's say you're getting 5% annual interest or 1% monthly interest, whatever. But January $100 is just $100. What happens in February? In February, this $100 gets interest, right? But then you add an additional $100 for the month of February that wouldn't get interest. What happens in March? So in March, this guy gets interest again. This guy from February gets interest, and you're going to add another $100 in March. This is really how retirement accounts grow, is if you keep putting money in. Because then you're getting interest on the early stuff, but you're still adding more money out of your paycheck, like $100 a month. So they're adding $100 every month, and you're getting 3% annual compounded monthly, though. So I should probably put up that formula that you probably forgot, right? I'm going to print this right on your test, so you don't have to memorize the interest formula. 1 plus R divided by N to the NT, right? This is your interest rate, and then this would be 12. Does that kind of sound familiar from the last unit? So it says, how can we figure out if we're putting in $100 per month and we're getting 3% annual interest compounded monthly? How much after 4 years? I'm just writing this so that for the video you can see what information you have. So how many compounds should I do? How many months is the money going to be going through this process? That would have been over here, January, February, March. That would have been 3 months, right? We had January plus February plus March. If I'm doing this for 4 years, how many months am I going to be adding in money? So your summation is going to go 1 to 48. So you are accounting for your 48 summations. So now what's your sequence going to be that's going to go inside? Your sequence is going to be your compound interest formula. So my compound interest formula, how much am I putting in every single month? I'm putting in $100, right? That's like my starting value, geometric sequence. So then I'm going to write 1 plus, what's my interest rate? 3% compounded monthly. So that's, remember, 0.03 divided by 12. Here's the important part. What goes here in a summation is n minus 1, not the number 48. The number 48 is over here telling you to do this 48 times. The number n minus 1 allows you to plug in month 1, plug in month 2. You need an n to know where to plug things into. N minus 1. So I want you to type that into your calculator and see if you can figure out how much would be in the account. If I just put in my money, I would do 48 times 100, right? 4,800 is what I have put in. But then I'm getting all this interest too. So you know it's going to be more than $4,800 if you did it right. So try typing it in because it's a little bit tricky with the parentheses. 1 to 48, 100, 1 plus. So this would be kind of maybe a raised to the n minus 50,093 and 12 cents if you do it right. Yeah, 5,5093 and 12 cents. So who needs help making sure they know how to type that? Yeah. Did you all get it? Yeah. Okay. Okay. Wait, okay. No. Math. Summation is down at trace, I think, like 0. What do we got? Get bigger. X. 1. I don't just need to be a 1. I can do this now. Okay. 1 was at the bottom. Just start at 1. Help you again? Oh. Yeah. You don't want to get it. I would just put that extra parenthesis there. That way you have to double up this. Like this whole thing needs to get raised to the power right now. Just that is getting raised to the power. Don't put a parenthesis between the plus. Okay, so now this is kind of something different. Instead of $100, what if you wanted to have $15,000 at the end of 6 years? So I'm going to change how much I invest every month. This is what someone who's your investment, person at Edward Jones or whatever, they're going to say, what do you want for retirement? You can't just put in $100 a month. You better be putting in $225 a month. So they use these formulas to project what you will have. So instead of $100, how much should you invest at the same interest rate, right? 3% compounded monthly, but you need to have $15,000 after 6 years. 6 years is how many months? What, 6 times 12, right? Is that 72? So I need to go, my top is going to be 72, but I don't know how much to invest. I'm going to put an X here representing I'm not sure what I need to invest, right? It could be $100, it could be $50. Now I'm going to write this, 1 plus 0.03 divided by 12 to the n minus 1. I want this to equal $15,000, right? And I don't want to have to guess and check all day, but you could guess and check if you forgot how to do this, right? You could plug in $200 and see how close you got, or $300 and see how close you got. So the one trick, this X, remember how I said over here, that just is my investment of like $4,800? This is really whatever X is times 72, that's a constant. You're actually allowed to pull the constant out in front of the summation. So I'm actually allowed to kind of just scribble out this X for now and move it out here as like the distributive property. So I can do this first and think of the X as like $7,200 being multiplied by 10. And now I can actually calculate my interest summation because this is just 1 to 72 of just the interest to the n minus 1 power. So you're going to have, you pull out your X, this is a number, and you can divide that number to the other side to solve for X. So this is a summation you can now do on your calculator, and you can divide it to the other side of the equation, and you'll get X. You're doing an interest summation on just the interest. Dividing your interest to the other side. You're going to take, so when I get math summation, I'm doing 1 to 72 of that parenthesis 1 plus 0.03 divided by 12 to the n minus 1 power. So that just gave me 7877. Right? I just did the interest summation, ignoring that there was an X there. I don't know why. There we go. So really what I have is X times 78.779 equals 15,000. How would you solve for X? Take 15,000 and divide by that 78.779. And it will tell you what your monthly investment would have to be. Does it have to be $100, $200? So I'm going to take 15,000 and divide by that answer, $190.41 a month.
So it takes away the guess and check. You don't have to keep guessing what you'd have to invest. Should I leave that up there to make sure you know how to type it into your calculator? Okay, why don't you try number 3. Think about how number 3 would be set up, the same or different from number 2. You have a different time frame, but you're doing annually, right? N before was monthly, now N is annually. See, and if you're not sure on number 3, I'll put it up in just a minute. 78, it came out to $190 and 41 cents a month, right? Is that how you feel about it? Oh, I think this is interesting, actually. If you are really saving for retirement or for something, and you know how much money you're going to get each month, even if it was like you're going to try to invest in the stock market, $50 a month while you're in college, how much would you have at the end of 4 years? You know, I think it is interesting to backtrack how much money you would need, because you're all going to have to deal with money and investing and saving at some point. So it gives you a little bit of power about, oh, if I invest in this, how fast does my money grow? What am I going to set this up as? Let's at least set this up. N is going to go from 1 to 20 this time, because it's not monthly interest, right? It's annual interest. You're only going to get 20 compounds in 20 years. I still like writing my X there because I don't know how much to invest. I'm getting 5% compounded annually. I don't even have to write it like this. I could really just write 1.05 to the n minus 1 power. I want to make my outcome be $75,000. So you're going to pretend that you're going to slide that X out front. You're going to calculate this interest. So this is a summation of kind of the interest. Then you'll have X times that, and you can divide your interest to the other side to solve for X. I think it's kind of cool. I don't think it's that much harder than the compound interest that you were already tested on last unit. And it's using series in a really powerful way that you can access because of the graphing calculators. So you don't need some financial advisor telling you what you need to invest. You can figure it out on your own. If I want to have this much for retirement, this is how much I'd have to invest. I can put it in and tell you what you should get. N goes from... Yeah, it sounds like you got the right number. That 33 number is what you get from the summation, right? That's good. Yeah, that's exactly it. So you actually have to invest quite a bit every year. So if you think about it, if you put aside, like if you got a tax return every year and you said, I'm not gonna spend my tax return, let's say you got 2,000 on your tax return. I'm just gonna put my tax return into this investment savings account. Pretend I never saw it. You'd have $75,000 after 20 years just from your tax return. This comes out to 33 about 066. You get 2268.19 as your annual investment needed. Yes, that's because it was right. And this one says you're investing it each year, right? So this is year annually. The other one was month and monthly. So yeah, there is a big difference because it changes your upper bound. Okay. I think I'm not going to do the maximum concentration. All right, so I'd like you to go back to, let's go to 513. I'll just focus my application problem around interest because we don't have time to do the medication dosage and the ponds and all this stuff because that would have been a lot of days on geometric applications. But if you just focus on investment, right? There's sequences with the number of steps or whatever, but if we just focus on investment, here are some options, and down below you're going to calculate how much you would have. So this says you will receive 7% annual on stocks compounded monthly. That's monthly, so you have to do like 0.07 divided by 12. 3% on bonds, and that's compounded monthly, so you do 0.03 divided by 12. And I did not even, I didn't give you savings as a choice because it's so little, so you can cross off savings. On number 1 and 2, you're putting in $100 every month for 35 years. So this is going to be in terms of months again, just like we did on that first page, example 1. This is calculating how much you have to invest. This is the problem where you pull out the X. So 1 and 2, you're putting in the amount and seeing what the output is. Number 3 and 4, you're solving for X. So I think if you base those on the examples we just did, I'm hoping you can do 1 through 4. And if that's the type of application problem that I put